Hi guys, so this is right here a problem that we were doing and I wasn't able to finish up right because the bell had just rang. So this was number 51, A and B. So I had explained right here, this was about the empirical rule, right? So what does the empirical rule state, right? And they call that the 68, 95, 99.7 rule. Okay, so what does that state? Just remember that we have right here 68% is within one standard deviation. So this is 68%, right? Within two standard deviations, we have 95%. And within three standard deviations, we have 99.7%. That's 99.7%. Okay, so let's use that to answer these questions. Now, as I said in class though, in this particular question, you could definitely conceivably just answer this using normal CDF and showing your work that way. However, if there's like, it could be like a multiple choice or something like that where it forces you to actually use the empirical rule. So let's do it how they said, using the empirical rule. But you can, once again, I want to make it clear, you can do, since this is right here, this data is approximately normal. They said it's modeled by a normal distribution. You could do this by using normal CDF, okay? Because it says it's modeled by a normal distribution. So let's take a look right here. Let's first redraw that normal curve that we had. So we had the mean was 9.12 and the standard deviation is 0.05. Okay, so 0.05 to the right is 9.17. 0.05 to the right again is going to be 9.22, just adding 0.05, right? And then 0.0 to the right again, draw a little bit better. 0.05 to the right again is 9.27, all right. So that's right here. That's one standard deviation, two standard deviations, and three standard deviations to the right. Now let's go to the left. One standard deviation to the left is going to be 9.12 minus 0.05 is 9.07. One standard deviation to the left again is going to be 9.02. And one standard deviation to the left again is going to be 8.97. Right, that's all correct, right? 9.07, 9.05, and this is 8.97. Okay. So, yeah, in class I felt like we had something slightly different. Let's just look what we had in class. No, I had that. Okay. All right, so, all right. No problem. Okay, so, about what percent of bags weigh less than 9.02 ounces? Now, again, as I said, right here, this is normal. So, I could conceivably just say normal CDF. The lower is negative 10,000. The upper is 9.02. The mean is 9.12. And the standard deviation is 0.05, right? Okay, but they said to use, please use the 68, 95, 99.7 rule. So let's go ahead and do that. Let's think about it that way. Okay, no problem. Well, what do we know right here? We know that, first of all, let me try to use a different color here to signify this. We know that 95% of our data is right here, from right here to right there represents, this is representing right here, 95% of our data. This whole chunk right there. So that means that right here, this chunk right here to the left, this chunk to the left that I already shaded, and this chunk to the right here, represent 100 minus 95, which is 5% of your data. Now, we only want that left-hand chunk right there, and it's symmetric, right? So all we have to do is just say 5% divided by 2, and that is going to equal 2.5% of your data. So there you go, right here. About what percent of bags weigh less than 9.02 ounces? Show your method clearly right here. We would say right here, all right, about 2.5% of your bags weigh less than 9.2 ounces. Okay, and then you could just reference your work right there. We said 100 minus 95. And then, you could just specify that we know that 95% of my data is from 9.02 to 9.22. So you can say 95% of our data is from the weights of 9.02 to 9.22. So right here you can just say, well, I subtracted 100 minus 95 and I got 5% and divided that by 2. Good enough, okay? Let's look at B. A bag that weighs 9.07 ounces is about what percentile in this distribution? Justify your answer. So a bag that weighs 9.07 ounces, let's redraw this right here so we can have a clear picture. And again, right here, let me just minimize it so I can just rewrite this quickly. And then down here we had 9.07, 9.02, and finally 8.97, right? All right, awesome. So right here. So this specifically asked right here, what? It says a bag that weighs 9.07 ounces is about what percentile in this distribution right here. So they're saying at this point right here, and what does a percentile mean? It means the percent that is less than or equal to that value. So that means that all this good stuff right here, what is this percent right here? We don't know, right? So, okay. So we could actually do this just by using normal CDF, right? Normal CDF, lower is negative 10,000, upper is 9.07, mean is 9.12, standard deviation, once again, is 0.05. But it said to use the empirical rule, right? So let's see if we can figure this out. Okay. What do we know right here? Well, we know that this little chunk right here is one standard deviation to the left and one standard deviation to the right. So this is right here 68% of my data. Okay, no problem. So what does that mean? That means that this chunk, and for that matter, this chunk right here, so these two chunks together are going to be 100 minus 68, which is 32% of my data. Now, unfortunately, I don't want both chunks, but it is symmetric. I just want the left chunk right here. I just want the left one. So to get the left chunk, I'm just going to go ahead and say 32 over 2 is 16%. So that gives me the answer right here. This is right here going to be, we know, 16% of my data, approximately. So I would say right here, justify your answer right here. I mean, we did show our work, so, we would just say about 16% of the, and this was weights in, make sure you use context right here, of the weights in ounces. Or less than 9.07 ounces. Okay, so that tells you right there that it's at the, it says right here, this answer the actual question about what percentile. So 9.07 is at the approximate, or about 16th percentile. Sorry. Okay. And we already did actually show our work up here. We saw 100 minus 68, 32. We just labeled left chunk 32 over 2. I think so we justified it. All right. So we're good right here.